Hello friends, welcome to the session on data structures. In this session, we'll be discussing about linked list. In this session, we will see what we mean by linked list, what are the different types of linked list, how the linked lists are represented in memory, and also we will see the traversing operation on the linked list. Friends, as you know that you are viewing this session on my YouTube channel, and do not forget to subscribe to the channel to see many videos on various subjects in the topics of electronics and computer science. Now let us start the session with the question what we mean by linked list. In earlier sessions, we have discussed arrays, and we know that arrays are being stored in the successive memory locations. Array is a collection of homogeneous data elements, and these elements are stored successively in the memory. If the array size is small, then there is no problem of memory. But if the array size is large, then the allocation of the memory becomes difficult. Also, you will find that the size of the array is fixed, and it is not possible to increase the size of the array dynamically. And in those applications where we are not sure about how many elements are there, then array can create a problem. Also, since the size of the array is fixed and the elements are stored in the successive memory locations, one can easily understand that the insertion and deletion of the element from the array is not easy. Because if you want to insert an element, then you need to create a space. And if you want to delete an element, then you need to fill that space. So you can say that these are the limitations of the data structure of linear array. To solve these problems, we can make the use of another data structure, and that is being called as a linked list. Linked list is a linear collection of the data elements, but the thing is that these elements are not stored in the successive memory locations. So it is possible that you can store these elements in different parts of the memory, even though they are the part of the same list. So every data element in the linked list will consist of a node, and the node will have the two parts. The first part is being called as a data, and the another part is being called as a pointer, and that points to the next element. And that is the reason this list is being called as a linked list, because there is a linking between the different elements of the list. So linked list, you can say, is a collection of nodes where every node will consist of a data and a pointer to the next element. So the first element can be called as a head. So head is a pointer which will point to the first element of the linked list. And the last element can be called as a tail, where it will point to the end element, and therefore most of the time the tail pointer value will be equal to null. Accessing of the elements in the linked list is much easier than that of the arrays, because in case of arrays, the computer need to compute the location of each and every element. But in case of linked list, the node itself will contain the address of the next element, and therefore making an access to the elements of the linked list is quite easy. The memory requirement for the linked list is comparatively larger than that of array, because one can easily observe that in case of array, we will require only one form of memory location where the information or the data values of the elements are stored. But in case of linked list, we will require the two columns. One column will represent the value of the element, and the another column will represent the link values or memory address values. And therefore, one can say that the memory requirement of the linked list is larger than that of the arrays. Linked list advantage of the linked list is that it is a dynamic data structure. That is, it is possible that we can grow the list even during the program execution. This is not possible in case of arrays, but in case of linked list, it is possible to increase the number of elements in the linked list. That is, we can grow the list even during the execution of the program. So as shown in this diagram, one can easily observe that this is the first element which will point, which will be a pointer. Head is a pointer which will point to the first element of the linked list. The first element will have the data value and a pointer to the next element. The second element will have a data value and a pointer to the third element. And this goes on. And normally the final element will have the data value. And since it is the last element, and therefore the pointer value will be null for the last element. So let us understand what are the different types of linked list. There are different types of linked list. Say for example, the first type is being called as a simply linked list. So this is a basic linked list where each node will contain the data and pointer to the next element. And the last element pointer will have the null value. Say as shown in this figure, this is the first element of which the value is A, and the next is the pointer to the next element. So in this way, the final element will have a value D and its pointer will have a null value. That indicates that this is a final element of the linked list. So this is the simplest type of list. But the problem with this list is that as far as the traversing of this linked list is concerned, then we can traverse only in one direction. That is, we need to visit A first, then B, then C, and then D. Another type of the linked list is being called as a circular linked list. So this is a singly linked list where the last node will point to the first node. So in this case, even the last node will not have a pointer value equal to null. As shown in this diagram, suppose this is the last element of the linked list, and still it will have a pointer, and this pointer will point to the first element. And therefore, this linked list is being called as a circular linked list. So circular linked list is very useful because in certain problems such as time sharing problems, we can make the use of such list. There is another type of the list, and this list is being called as a doubly linked list. In this case, each node will contain two pointers instead of one pointer. Now each node will have the two pointers. The first pointer is being called as the LPTR, that is the left pointer, and the second pointer is being called as a RPTR, that is the right pointer. So as shown in this diagram, suppose this is our first element, so it will have the left pointer and right pointer, and similarly the next element will have the left pointer and right pointer. So the advantage of this list is that we can traverse this list, that is, we can visit the elements of the list in both ways. That is, we can travel in the forward direction as well as it is possible to travel through the linked list in the reverse direction. It is possible that the rightmost element in such a list will have RPTR is equal to null value, or the leftmost in such a list, the left pointer will have a null value. So the operations that can be performed on the linked list, there are various operations we can perform on the linked list. The first operation is being called as a traversing. In traversing, we can visit each and every element of the linked list. It is possible that you can perform the operations such as insertion and deletion. In insertion operation, we can insert a new element into the linked list. In deletion operation, we can remove an element from the linked list. It is also possible that you can perform the operation such as searching a linked list. That is, whenever an element is present in the linked list or not, that can be determined by using this operation. So various operations can be performed on the linked list. But as far as this session is concerned, we are going to discuss only first operation, and that is the traversing operation of the linked list. So before we actually discuss what we mean by traversing, let us understand how the linked lists are represented in the memory. So the advantage with the linked list is that it is not necessary to represent all the elements in the memory in successive memory locations. So it is possible that you can represent the elements in the memory which may not be in successive memory locations. So they can be stored anywhere in the memory space. So whenever we have certain space available in the memory, then in that part of the memory, you can store those elements. Now it is necessary that in order to maintain the linked list in the memory, you require two columns, or you can say that you actually require the two arrays in the memory. The first array is being called as info or data, and the second array is being called as link or next. So the first array data will hold all the values of the elements, and the second array will hold the memory address of the next element. Say for example, we have been given a linked list where the first pointer of head node is 1, and the first node itself will have the value 13, and its next will have the value 4. The second node has the value 15, and its pointer value is 6. The third node will have the value 19, and its pointer value is 8. And the last element will have the value 57, and its pointer value is null. Now suppose if this is the linked list, then we can represent such linked list in the memory as shown in this diagram. So the first pointer is the header, or many times it is being called as a start pointer. So it will point to the first memory location address. So the first value is 13, and the next column or the next array will contain the pointer to the next element. So the next element may be stored at somewhere else, not necessarily it should be stored in the successive memory location. So the second element will be stored at the position of 4, of which the value is 15, and it will point to the next element which is stored at the position 6. Then at the position 6 of memory, the data value will be 19, and the next value will be 8. And at the position 8 of memory address, the data value will be 57, and the next value will be 0. So it will indicate that it is a null value, and this is the last element of the linked list. Now let us go for the discussion of the first operation on the linked list, and that is being called as a traversing operation. So traversing operation of the linked list means visiting each and every element of the linked list once. Now suppose we have a start pointer or the head pointer which will point to the first element. And suppose we have an array called as an info which will contain the values. And suppose there is a array next which will point to the next element. Then we can write the algorithm in this fashion in order to perform the traversing operation. Now, if the start is equal to null, then it means that the list is empty, and therefore we will exit the algorithm. Otherwise, we will put the pointer is equal to start, and we will repeat the steps 4 and 5 until the pointer value is not equal to null. So we can access each and every element by using pointer makes an access to the info field, and then we will set the pointer to the next, and then we will make an end to the repeat. So in this loop, one can easily observe that we can make an access to the different elements of the linked list. Now, suppose we want to print the element of the linked list, then in such a case, we can modify the steps of the algorithm in this way. We can set the pointer is equal to start, and then we will repeat the steps 3 and 4 while pointer is not equal to null. And then we can write or we can print the info pointer. That is, we will print the corresponding information value or data value of the element of the linked list. And then we will set the pointer is equal to link pointer. That is, we will change the value of the pointer to the next element. And this loop will be executed until all the elements of the linked list are visited and we are printing or we are writing the data values on the screen. Now let us write down a C program to perform the traversing operation on the linked list. Now suppose we have included the standard input output header file, and also in this program we will require the standard library.header file. Now in order to create a linked list, we need to make use of the structure in the C program. So this is our node, structure node, of which there are two data values. The first one is the data integer data, and the second one is the structure node star next. So it will actually contain the address of the element. And this is the pointer which will point to the start element. Now we can write the functions for creation of the list and for traversion of the list. So to create a list, we will write a function create list, and to traverse a list, we will write a function traverse list. This is our main program. In the main program, we will ask the user to enter the total number of nodes. So how many nodes user want to create, that will be asked by the user. And then we will record this value of n. And then we will execute this function create list, of which the argument will be passed as an n. And then we will print the message for the user for the data. And then we will execute this function traverse list so that all the data values will be printed. And finally, we will return 0 to our main function. So this is a function that is being written for the creation of the linked list. So one can easily observe that we need to make use of the structure for the creation of the linked list. So initially we will write head is equal to structured node start memory allocation function size of structure node. So this is a function that is being used for the allocation of the memory to the start element. And if the memory is not allocated, then we will print the corresponding message unable to allocate the memory. If the memory is allocated, then this if part will not be executed. And then we will ask the user to enter the data for the different nodes. We will read the data, and then we will link the data filled with the data by making the use of the statement head arrow data is equal to data and head arrow next is equal to null. So these are the statements that are being used to make an access to the data field and address field. And then we can create the n minus nodes and we can add it to the list. For that, we need to make the use of the for loop. So every time we will make an allocation of the memory, and if that allocation is not done, then we will print the corresponding message unable to allocate the memory. Otherwise, if the memory is allocated, then the corresponding data and the corresponding fields will be allocated the values. And then we can display the contents of the memory by making the use of the function called as a traverse list. So initially we will check if the list is empty. If the list is empty, then the corresponding message is being printed by checking whether head is equal to null. Otherwise, we will make a use of the while loop, and every time we will make an access to the data elements by making the use of the statement printf data is equal to temporary arrow data. So this statement is being used to print the data of the current node. And then we will move to the next node by making the use of the statement temporary is equal to temporary arrow next. So when you type this program and when you execute this program by using C compiler, then initially the message will be printed on the screen. Enter the total number of nodes. Suppose we want to create a linked list of 3 nodes. Then it will ask for the data of node 1. Suppose we enter 12. Then the data for node 2. Suppose we enter 32. And then the data for the node 3. And suppose we enter 44. Then you will find that the visit to the each node is being done by the program, and finally we will get the message that the data in the list is data is equal to 12, data is equal to 32, and data is equal to 44. So thank you friends for viewing the session. Hopefully you have understood what we mean by linked list and how to perform the traverse operation on the linked list. Thank you all for viewing the session.